A few days ago I made a video showing how to splice urethane belt material. In that case, though, I made a straight across cut rather than a diagonal cut. And I utilized a vise on my milling machine. And a number of people brought up the question as to whether a diagonal splice might be better in some ways. And I think it might, in that it might be a little quieter as it goes over the pulleys. And it may offer some more strength, although I think the strength issue is really not much of a concern with this material, as it's very strong regardless. But I did want to come up with a method that might be applicable for folks that didn't have a milling machine and yet wanted to splice their belt, and also a method that would not require that the splice be made on a surface. But there were folks that talked about their older style lathes that used belts and didn't think they'd be able to splice in place the belt using the method that I showed. So this is a 3D printed solution. Could be made out of wood just as well, but 3D printing for me was easier. Where I made a base plate with a couple of steel inserts that are going to attract magnets. You'll see that later. But this is the base, and this could be held in any position. I guess it could be attached to a board, for instance, if you're working on a lathe, and set it up in space like this, where the pulleys might be up here and down here. Anyways, this is the base of the system. And then here are a couple of pieces that have powerful magnets, neodymium magnets in them. And what that allows is for me to move the belt in position and then just leave it, and the magnet holds this piece down firmly and also tends to keep the orientation. When I push the belting material together, it'll hold it in place like that. So I don't have to fiddle with clamps and whatnot. And then on top of the next part is the belt does snap into the place here more or less, in that I match the dimension of the slot pretty close to the size of the material. And then this top piece goes on, and these pegs, I don't know if it'll show in the video very well or not, probably won't, but they have a little flare on the top that causes the piece to sort of snap into place. So you just put this on top like so and push it down, and it kind of clicks into place, and that holds the material quite nicely. This also serves as a cutting jig. You can see I was playing around here a little bit with the belt material, melting it and whatnot previously, but I wanted to make a splice here live. It is possible to adjust the stick out of the belt material just by getting behind it and pulling like so. You can see that I'm able to move that belt material back and forth a bit, as you might desire, but it still holds it well enough that it'll allow the splice to be pressed together nicely. So I think the next step might be to go ahead and just trim off the excess here, and for that a single edge razor is quite nice. A good sharp box knife, variety of things can be used, but the razor blade seems to work out pretty well. And for that, I just, without getting my hands in the way too much here, I hope, just take that razor blade and, using the edge of the holder there as a guide, make repeated cuts. It could be done all in one slice, I suppose, but I feel like I have a little more control that way. And then we have a nice flush cut here. I'm trying to stay in the camera. We have a nice flush cut, and we'll do the same on the other side if necessary. It may already be trimmed adequately. Let's see. Push this in here as before. That actually looks like a pretty nice cut. So I'm going to push out just a little bit of material here so that it's standing proud. I don't know exactly how much to do this necessarily. Something on the order of maybe between a 1/16 and an 1/8 of an inch. I think that's what I have there. Let's go ahead and snap the top piece on. There we are. And I'd probably better move that other side out a little bit so it's not flush. We got to have some material sticking out to be heated and to squeeze together. So we're pretty much ready to go here. I'm going to put the one piece in and you can see that it snaps into place. And because the disc here is centered on the neodymium magnet in the original design that I made, by the way, in Onshape and then 3D printed on my Prusa printer, that tends to want to push the pieces together, and that's, I think, desirable. We want to hold them apart a little bit like this, if you can see that. Hopefully the light's adequate that you can see in there. Hold a little bit apart, put the hot metal in there, and then push everything together and just let it sit, and that should make a nice weld. I will also mention that in the previous video I used a heat gun to try to determine the temperature of the steel that I was using, and that was pointed out by a viewer to be pretty inaccurate. I knew that there was a problem with shiny steel, but I did another video recently on using a heat gun, Tempel, T-E-M-P-I-L, sticks, and the color of the steel as a means of determining temperature. It turns out, of course, that there was a big discrepancy in the shiny side of the metal. On the other hand, if I left one side of the metal with its original mill scale, that kind of grayish coating that's on steel as you buy it from the supplier, and that side registered nicely with the heat gun because it's dull and has good emissivity. The shiny side, not so much. It was hundreds of degrees cooler registering than it actually was. Well, here we are out in the shop now. I didn't want to do the heat business in the kitchen, so came out to the shop and put the setup on the corner of my table saw, clamped it into place, and on the corner that allows that piece of belting to loop underneath and be out of the way. So what we need to do is take this piece of metal and heat it up to about 500 degrees, slip it down between the pieces of urethane, let it heat up the edges of the urethane, pull it out, and push it together. I'm going to put a couple little pieces of steel here that will prevent the heated piece of steel coming down too far and touching the base here. This is printed out of PETG, and I know if this is very hot that it will possibly distort the PETG, that has caused a little gouge in it or whatever. We're going to try to avoid that. So that should give me a little guidance as to how far down to put that piece of steel. I think it's time now to go ahead and heat it up. We'll see how we come out. I know that it takes about 20 or 25 seconds to get this piece up to temperature, so we'll go ahead and heat it for that period of time and then measure its temperature and see what we see. I'd like to get it around 500 degrees as I think that is a desirable temperature from what I read to fuse the urethane. Yeah. So let's see where we are at the present time. That's registering around 450, 460 degrees, 490, so probably right close to 500. Let's see if the temple stick melts nicely, so tells me that we're about where we need to be. Let's go ahead and give it a try. So we're down between the two pieces of metal, pushed it together momentarily, pulled it apart, pushed together firmly, and just let it sit. We'll come back in 5 minutes or so and see what kind of a joint we got out of that. So about 5 minutes have gone by. Let's see how this turns out. Work these up out of the base there and then pop the tops off. There's that. This one. And it looks like we have a good join line there. The material raised up all along the edge, but it doesn't look burned either. In other words, it's the same natural color. What I'll need to do next is trim off that little bit of flash, and to do that I intend to use the single edge razor blade, and probably will put the piece down on the edge here as that'll stabilize it. I'm going to shut the camera off for a moment and we'll be right back. So now I've got the band bent over this bar, so to make it a little bit more convenient for trimming, we'll see how this all goes. Just trying to slide the blade along the surface there, and you can see that that's going pretty well. I don't know that I have to show you the whole process. You get the idea. I think I'll stop here and do the rest offline. Well, I have it trimmed up now, and the resulting splice appears to be very good. You can just feel that ridge along there, but there is no offset height-wise of the belt from one piece to the other. That I think is important. I really wanted to make sure that I got a nice smooth running belt that way, and linearly you can see that that belt is nice and straight as well. In a moment we'll test that belt by putting a scale on it and looping it over my foot, and we'll see if it'll hold 100 pounds of pull. I'm quite sure it will, but let's just do that just because. Okay, well, here we are. I've got my scale looped around the belt that we just made. I'm going to try to put it on my foot here, give it a good hard pull, and hopefully allow you to see the scale as I do that. We exceeded the scale's capacity of 110 pounds or so, and it has held nicely. So the strength of that weld seems to be very good. In actual use, it would be very surprising that it would be subjected to that kind of pull.